All right, thank you, Amy, and thank you to the Assembly Show for having us today, and thank you to all of you for coming to this little event. So good morning or good afternoon if you're on Eastern Time, but what we'll talk today about is a little bit of history, a little bit about the assembly worker and ergonomics and some things we can do to help them and manufacturers solve some challenges in the workplace. So, well, looking back, if you saw that little video clip, our company actually celebrated a birthday last month. Our company brand was founded in 1914, 100 years ago, so it's a big milestone for a company to be 100 years old. So I looked at some other companies that also reached that milestone. So, and there's some brand names we might know of a variety of interesting industries, but we have Merrill Lynch. I don't know if anybody came here in a Maserati, but Maserati is 100 years old, as well as Chicken of the Sea. Interesting that they did the chicken tuna thing and named it a chicken, but it worked for them. So Toro Lawn Equipment is 100 years old. Booz Allen Consultants, Speedo, the swimwear company. We thought this might be a good uniform for the booth this year at the show, but that got lost in the Human Resource Department somewhere. MSA, Mine Safety Works. This is actually a company that recently bought some equipment from us, but reflects even 100 years ago that safety of the worker and the operator was becoming an important issue. Jolly Time Popcorn was an innovative company, not because of popcorn, but because of the way they packaged it and kept it fresh. And then Greyhound Bus represented, you know, mass transportation and people wanting to move around in an ever shrinking world. So our innovator happened to be this man, Marcel Desoutter, and the Desoutter brothers were very interested in flight at the time in the early 1900s. And if you saw in the little video, there actually was an airplane crash, a person lost their leg, and our company was founded on the business of making artificial limbs. And then it was through the business of building those that actually came about the development of industrial tools, and thus is the tool company that it is today. But even at that time, transportation was becoming such an important industry, and it remains so, certainly to this audience at the Assembly Show. Now in 1914, you could get a Harley-Davidson motorcycle. They'd already been around for a few years, so by 1914, you could already get one that included many new features for $200. And then the Dodge brothers launched their first automobile in 1914. Interestingly, when you look at the marketing of the car, they already had the good, better, best value. For $975, you could get this car fully equipped. I think it included the roof. But for, what is it, $850, you could get the car without a starter. So I think the starter's standard on all Dodges now, but at that time, you could get it without it. But those were changing times as well. There was a lot of worker unrest as assembly lines and mass production came to be. And so certainly in the early 1900s, you had a terrible conflict in World War I. And you also had revolution, the Russian Revolution, a workers' revolution about working conditions, unsafe conditions for workers. So even today, and this might be a bit extreme, but if your company, if you're a tooling decision maker, and this is your company, and your workers look upon you, you're a bad tool company, this could be your workforce, you know, and this could even be your car that you paid extra for the starter on it. So joking aside, it's an important issue that we deal with when we talk about the worker and how they interact with the workplace. It always has been from the beginning of manufacturing. How do we take care of a worker in a mass production environment? So if we were to think of freedom like a Bill of Rights, what could we do for the assembly line worker? It might be something like this. We want to protect them from injury. We want them to have freedom of movement, the ability to do their job correctly, and the freedom to work independently without having to be overburdened with things that allow them to or hinder them from doing their task that they're supposed to perform. So how do tools come into play with this? Well, the tool is so important because what we deal with in portable tools and portable assembly tools, that's the union. That's really the union between the human being and the mechanization of the assembly line. It's what the human being feels and touches. So it's very important when we're dealing with this product that's held by a human being all day. On the other side of that equation, though, is the manufacturer. And while we talk about we want to give freedom and freedom of movement to the assembly line worker, On the control side is the manufacturer and the ability to further control processes, get better quality and productivity from what we're doing. So if you're an assembly line supervisor, you might feel like this. You need to actually be in the head of these workers so they do the job correctly. You really need to control this to a fine level of detail. And if you're the tooling decision maker, you have your own set of issues that you're trying to work through. So we use the word innovation. How can innovation help solve some of these problems? What can our company and the other companies that are represented here today do? Well, it's really like a scale. There's really two sides, and which side do we put more weight on? On the one side, we have the effort to improve conditions for the assembly worker, and on the other side, we have the effort to improve processes and productivity and quality for the manufacturer. So how can we achieve these two things at one time? The assembly worker would say they want a tool that's comfortable. They want something they can use in one hand. If an assembly worker uses a tool with one hand, they're about 30% more productive if they can use a pistol tool or a one-hand type of tool. Can they use it in their left hand or their right hand? Can they use it wearing gloves? Does it resist slipping if there's lubrication in the environment? Does the tool itself tell them that they did their job correctly? When we look at it on the bigger side, the bigger picture of ergonomics, a new product now with us and some other people would be a no reaction tool. Can we run a bolt down and have no reaction for that operator? That's a big issue. But even in addition to that, you have, does an operator run a tool and say if they're inside an automobile, do they have to look back at a controller? Are they always twisting and turning to look at some device that tells them they did their job correctly? Can the tool do a sequence? Can it take them through their assembly process? And then if it is attached to a cable, is it flexible? And can they manage that, or are they constantly fighting something in their workplace? On the manufacturing side, cost is always a big issue. When you look at cost of a tool though, or an assembly tool, there's a lot more than just the ticket price of what that tool is. To provide true value to the manufacturer, we talk about the cost of repair, the cost of the energy that drives the tool. There's a lot of movement away from compressed air as a force that drives tools and the use of electricity. So there's much more to take into account than just the cost of a tool per se. While a tool may up front be more expensive, in the long run it may be much more productive and cost effective for the factory. Time is always an issue on the assembly line. So we need tooling that meets cycle time, that keeps the assembly line productive. And then when we talk about quality on this side of the scale, we talk a lot about torque. But even more so than torque, it's a question of, is the job done correctly? And that means, did we cross thread something? Can we detect a stripped screw? Was there a missing part? Can we control a line process with the tool? And again, does the tool tell the operator what it does, or that it did the task correctly? So we look at this from the manufacturing side, but there's one piece of this that's really on both sides of the scale, and that would be ergonomics. Because bad ergonomics in the workplace can equal big costs in dollars and costs in productivity. OSHA determines that about $20 billion a year is spent on workers' compensation claims. So that's a huge risk for the manufacturing plant. Of those injuries, about 2/3 of them are repeated trauma to the wrist, to the elbow, or the shoulder. And if your workforce has a number of women in the workplace, women are more susceptible to these types of injuries just because they tend to have a smaller bone structure than the men do. So very common theme in industry that this is a hazard that health and safety managers are aware of. And this is important, even if an injury cannot be tied to a single event, a specific accident that may have happened. If you give a worker a tool and they use that tool correctly over a 10-year period and they develop an injury, they can hold that company liable and say that the workplace was unsafe and compensation benefits have to be paid. So ergonomics is a critical factor right now. So what we'll do right now is just look at a few tools that we have to offer to solve some of these issues. And the first of which we'll talk about, how would we free somebody from repetitive strain? How can we solve that issue in the workplace? And this particular tool was truly an innovation that we showed last year at the show, but it's the Desoutter ePulse. So what we have here are two DC tool systems. They look identical. The difference is when I run this tool, which is our regular tool screwdriver, I'm going to run this to about 12 Newton meters. That's about 9 foot-pounds or so. So I run this down, and that gives a little twist there. So if I'm, say, in an automobile doing a brake pedal application, and I have to reach out with my arm like this, you know, and kind of find the screw and get that on there, that gives me a twist. I think if I do enough demos, I can get a workers' compensation claim, but that's the traditional tool. What we launched as a way to solve that was a tool that actually pulses, except it does not have the traditional oil pulse chamber in it. It's truly electronic. So with this tool now, I can actually run this down, and that's going to pulse and give me a green light. And I just ran to 12.3 Newton meters here, traditionally, and 12.27 Newton meters there. So I can back this off, run it again. So again, I'm in that hard to reach point. I'm on top of that piece of agricultural equipment or inside an automobile. I can do my assembly. I literally can hold this tool with 2 fingers and run that down. So it's a huge improvement over the reaction forces for the operator. When we talk again about the operator, well, what about the control side of that? That's a fully transducerized tool. So we get full control. We can save data, save results, and it's all electronic. There's no mechanical pulse chamber in there again. Neat thing about that tool as well is you can actually adjust its wavelength for the pulsing, so it's adjustable for a soft joint or a hard joint. It'll program completely different for the two, but it can do both. You literally can have the soft joint here, and then you can have the hard joint here and have programs for each one. So big improvement as far as ergonomic reaction and some of those repetitive strain injuries that are dealt with in the workplace. But ultimately, what do workers want to see? They want to see a break free from the airline. They don't want to be attached to the airline anymore. So the next step in that is naturally what we would have cordless tools. These would be battery operated, cordless clutch tools. So, and again, I can reach out here and see if I got the right bit on there. So I can run that down. I got a good run down. And again, ergonomically, or so I don't have to look around, I get an indicator right on my tool that this job was done correctly. So this was not so much of an innovation recently, as you'll see a lot of this type of tooling in the show and in the workplace. But key things here are battery position. Are there different sizes of battery? You can have a smaller one for lighter weight, bigger ones for longer life in the workplace. Indicators on the tool, pistols and right angle tools with headlights, you know, you can see your operation. So a lot of innovation there, and then the tools can be adapted, as you see in the lower left hand corner, can be adapted to the specific axis that you might need to get to. So these are things that us and manufacturers are working on now, but a step up from that, actually, first, before I mention that, what I wanted to say was, in addition to that, we're giving the worker the freedom, but we want that control. So you could use this tool wirelessly with a Poke-Yoke box, so now you still have that line control. The operator is in the vehicle doing their job, but yet you still can get that signal to your assembly line that the job was done correctly. But if we want a better control than that, then we would move to something like this. And this is what we call the B-Flex from Desoutter. There we go. And what this is we look at the traditional spring clutch tool. This has a spring clutch, so not going to be as accurate as something like this. This is a full DC tool. The difference is, instead of having a controller that we have to work from or a PC to connect, we actually program this right on the tool. This is all self-encased within the tool, so everything I do is right on this tool. And I've got a nice easy trigger. I can use this with gloves. It's got a nice grip if we're in a lubricated environment. But with the B-Flex, we have a fully portable battery tool, but it's a fully transducerized tool. So it's just like a DC system. Very easy to use and light, and there it is, the screen that you can see. You'll actually get a torque readout on the tool. So here we'll run our B-Flex down. So now I actually run that tool and my tool turns green. I get a green light indicator. I've got a good torque. You know, if I'm the operator, let's run another one here. You know, I can see that, yep, I just got 8.060 Newton meters. Has a resolver-based motor, so we can measure angle as well, so we can detect the strip screws and missing parts and this kind of thing. So this was a step up from this tool for us. So this is a new innovation coming into the marketplace right now. And again, if you think of some of the places where workers have to operate inside equipment, inside automobiles, doing the seats and airbags and different things, great tool for access like that. But some would say, well, that's great, but we'll give you this for control right on the screen. We can password protect the tool, so those riding assembly workers are not changing their torques, and you can see results, look back at the type of work you did, and no need to program on the tool or the PC. But if you want that, if you need that level of control, the next step from this tool actually looks exactly the same. And from us, that would be a tool we call the EAB COM. And what EAB COM is now, through a Wi-Fi network, we connect to a traditional controller. From us, it would be our CVI3 controller. Now we have the ability, multiple parameter sets, multiple rundown strategies. We're going to see green lights on the controller with torque readouts, as well as on the tool, just like you saw here. Additionally, we can tie that into a network and we can save data and store it. We can also send that to an iPad. So if you're sitting in your office and you want to know what's happening on the assembly line, you can actually check your network. You don't have to go down and look at the assembly station or even pull it up on your computer or your laptop. You can check it live on your iPad as far as what's going on. We can demonstrate that back at our booth if you'd like to see that technology. But for data then, we talk about the ability of the operator to move around, but you want to see results and statistics and things like that. So with that system with CVI3 then, you really get the full level of control that you need as a high-level assembly company that's doing critical joints. So we talked about that good, better, best thing with the car earlier on, and that really exists now in the assembly tool world as well. Now when people come to a show like this, we like to see concepts. And you know, what's coming? You know, this is what's here now, and there's a lot of things you can see at the show, but what's coming? What's the future going to look like? So we'll let him get going, but what the future really is going to be an interactive workplace. And we talk about the mechanics of the tools, and while improvements will continue to come in the mechanics of the tools, like we see in the e-pulse, where we can move away from the oil pulse chamber, what the future will hold could be any number of things, but an assembly station might look something like this. You might have, you know, a number of different tools, pistol tools or right angle nut runners. On the tools themselves are barcode readers. A lot of operators have to scan something in their workplace, but we can take that movement away if we put the barcode reader right on the tool, and they can scan right from it. Tools might have multiple heads, and these are some things that exist now, but things that not a lot of people are using already, with multiple different sockets. We keep those sockets in socket trays, or even different heads. You can change out the head for one application and then do something else. It's great in the aerospace industry, or great if you have one production run and then you want to do a different production run. You can actually change heads out on a tool, and that would all be identified by a socket tray. Some of you may use an HMI interface. So as the tool works, there's a visual screen where the operator gets to see what they're supposed to do. But in coming days, you might see something just like you'd see maybe an NFL quarterback wears that wrist brace and they look at it for a play. The time might come when the operator actually can look at that and see what they're supposed to do next or get their results. So again, if you think of somebody working in a large piece of equipment or inside an automobile, again, they don't want to look back at that controller to see what happened. That information is right there with the operator. Torque testing tools would be part of this process, wirelessly connected. We can still have the visual and audio signals that we have now, but the idea is to bring that to the operator so that they don't have to look and seek those out anymore. Again, torque testing tools to test capability of tools before they do a rundown. And then lastly, the kind of the brain of this whole thing, we think of the traditional controller, that big box that we have to hang on the I-beam and connect cables and things. In the future, that might not be such a big box. It might be something very small, almost like a large size calculator or something. We might not even call it a controller. It might be a processor or the brain of the operation. But the idea is as we advance to make things for the operator much more simple in movement, but at the same time actually improve control for the manufacturing plant. The operator of the future, man or woman, might look like this gentleman, where you have the tool and they're ready to go. Their processor is not now on the I-beam on the side of the wall. It's actually right to them in a belt or nearby. And they're actually not wearing safety glasses, but they would wear Google Glass. And if you're familiar with Google Glass or not, you can do some pretty cool things with it. In the assembly world, what we can do is actually so that this operator now doesn't have to look at a chart or a screen to see what he's going to do. It's what he sees. It would look something like this. So if, for instance, he looks in an engine compartment, he's going to see the part he's supposed to work on. And on the right side, he'll see the process he's supposed to do. He'll see the torque level he's supposed to run. It's going to tell him what he's supposed to do on top as far as the 2 screws. And then he'll get a green or red light, whether he did that correctly. And while we look at this and we say it's rather futuristic, things like this are really not very far away for where this industry is going. So when we look back to kind of where we started this little talk, can we help the operator? Certainly we can help the operator. There's a lot of products now with our company and here at the show where you can really help your people and processes be really free from injury and reduce those. Allow them more freedom of movement than they might have now, and the freedom to do their work independently. And you'll have this happy workforce instead of the people turning your car over at the beginning. But we look back at that scale and those 2 sides of how we're trying to balance these needs on both sides. We have the operator side and the manufacturer side. And really we talk a lot about innovation, and it's what I started with. We talk about companies that were innovative, but it really isn't companies that are innovative. It's really people. People are the innovators. I find that people that come to shows like this and attend talks like this even tend to be the ones that are thinking about what are the new and better ways to do things. And if you're one of those people, you can find that win-win on both sides of the equation for your production facility. So with that said, I'd like to thank you for your time today. That's a little bit of an overview of some things we have to offer to solve some of these issues in the workplace. We'll be at our booth all day, of course, to answer any questions you may have. So thank you very much for your time. I think we're good to go. So thank you very much.